In the previous video, we discussed the difference between horizontal and vertical scaling and the preferred approach when scaling up software applications. Next, we also discussed the significance of using an application load balancer and some of the different ways it distributes workload among application servers. The focus for this video would be to add the application load balancer layer to our current architecture and deploy our application at scale, thereby making it a scalable service. Let's dive in. Let's go back to the Amazon console and look for Elastic Container Service. That is this option. Or you can just type ECS. Onto the home page, click on clusters, and just like the previous video where we ran our application, we'll just create a new cluster. We'll name this cluster ECS Scalable Cluster. And for infrastructure, I will again use AWS Fargate. I'll keep the default options for monitoring and tags and just create the cluster. While the cluster gets created, I'll go to task definitions and create a new task. So again, choose the first option here. For my task name, I'll choose AWS Scalable Task. For the launch type, I will use AWS Fargate. And for operating system and architecture, I'll use Linux ARM64. Again, for the same reason that when we built the Docker container, this is the platform flag we passed. For my CPU size and memory, I'll choose 1 CPU. Memory would be 3 GB. That is the default option. And for task execution role, we'll use the same role we used when we were trying to test our application. That is the ECS task execution role secret. For task role, I'll use the same role. For container, that is a Docker container, we need the URI of the image. So let's just go ahead and create a duplicate tab. Go back to our console and search for ECR. Once we are here, go under the LangChain Streamlit repository, and this is the URI we need. So I'm just going to go ahead and copy that. For name, let's just give it container1, and for image URI, we paste the URI which we just copied. That is for LangChain Streamlit. We know that our application is running on port number 8501. Next, under add environment variables, we just click on that and we enter OpenAI API key. And now we need the ARN of our API key. So we on the AWS console, search for secrets manager. This is the same stuff we did in the previous video. So now we need the complete ARN of our container image. So we just copy it, we paste it here. And for value type, we'll again choose value from. And for use log collection, we'll add a new log. Let's name it OpenAI test. Value would again be the same ARN of our secrets manager key. And this value again would be value from. For health check, container timeouts, these values would be kept as optional. I will not be making any more changes with them. And I'll just go ahead and click on create task. So let's just go in under task definition, the task has been created. And if you look at the cluster has also been created, but it does not contain any task attached to it yet. So previously, when we were trying to run this particular task, all we were doing was doing more of a local testing on AWS. That is only for our use. And if we expose that particular application to other users, it might work, but only to a certain point. If the number of requests exceed a given mark, then the application would start breaking down. So in order to add that scalability to our application, we'll create a new service. So to do that, we select the task and under deploy, we click on create service. After we click on create service, we need to choose a cluster which we have previously created. Now there are two options here, capacity, like compute configuration. Under there is an option for capacity, provide strategy, and launch type. If we do If we choose the first option, we could distribute the way our application responds to user requests. That is, 40% of the user requests could be handled by Fargate, another 60% could be handled by, let's say, EC2 or something, or maybe like 80% by Fargate, 20% by EC2, so on and so forth. But we want all the requests to be handled by Fargate, so we'll choose launch type as Fargate and choose this default option, that is latest. Under deployment configuration, since we are not using Amazon's code deploy service, we cannot use, the rolling update option. So I'll just talk about that in a second. So we'll just choose the default option which we are given, that is service. Let's just give our service a name, which is, let's say, demo service. We want just one task to run, so we'll just keep it value as 1. And as you remember, like I was talking about Amazon's code deploy, so that option is basically visible here. So if we use Amazon's code deploy, then we are given an option for blue green deployment. But since we are not using that option, we'll be just choosing rolling update. And we'll keep these two options as they are. Once that is done, all these other values, that is rollback on failures, we will not be making any more changes to it. If there is a failure in our deployment, if something breaks down, let's say container image breaks down, that particular image would totally be removed from our entire service and a new image would be added. So that is what it means. For Service Connect and Service Discovery, we won't be making any changes. We'll just go ahead with the default options. For networking, we have been provided with the VPC and a subnet and security group. So again, we won't be making any more changes to this. We'll just go ahead and click on the default option which has been presented to us. And we want a public IP, so make sure that this option is turned on. After doing all these steps, the most important part now is to add a load balancer. So let's just go ahead and click on load balancing. For load balancer, the option we have is configure a load balancer to distribute incoming traffic across the tasks running in your service. So we are presented with 3 options. None, that is, we don't want to add a load balancer. We want to add an application load balancer or a network load balancer. There are different kind of load balancers. So we'll just choose the second one. And then comes the option that do we want to use an existing load balancer, or do we want to create a new load balancer? So we'll just choose this one, that is create a new load balancer, and we'll just give it a name. Let's say test load balancer. And this health check grace period basically means like how frequently do you want your load balancer to keep checking on your container images. So if we go back to our deck and go back to our slide, the load balancer here would basically keep checking our container image after every X number of seconds. That is, and if it sees that this particular container image has failed, it will remove it from this entire architecture, and it will make a replica, reinitialize the whole image, and then that image would be added here. So again, we will have 3 images, so on and so forth. So that is, we should give, let's say, 30 seconds. There's also an option for info here. You just click on that and read it. Choose the container which we want to use with this load balancer. We have just one container because that is the container which we used when we built this task. So if you remember, like we gave our task container, we gave our task a name, the container in our task a name, which was container 1. So that is what's being populated here. This is a very important step that we make sure that the load balancer, that is this load balancer, refers to the Docker container and listens to the health of the application running inside it on the same port as the port which we used when we were building the application. So that port was port number 8501. That is, the application running inside the Docker container will use port number 8501 to receive the request and send it back. So this particular load balancer will send those health checks, that is pings, to our application on port number 8501. And if the application responds back, then the load balancer will know that the application is actually working. So we have to change this port and change it back to 8501. So the next part is, okay, so that is under service auto scaling. I'll talk about that in a second. So the next part is the target group. Let's just give a name, let's say test group, and the health check path. So we won't be making any changes to this path. It's very important that you don't change this. If you change this path, then the load balancer will not be able to make a connection with your Docker container. So just go with the default option here. Next part is where we add auto scaling groups. Auto scaling groups make sure that your application can be scaled up automatically as workload increases, and scale down too when we have fewer users testing the application. So let's just go and click this option, and we will enable auto scaling groups. So minimum number of tasks which we want to run is 1, and maximum number of tasks which we want to run, because this is a very small application, let's just say 2. Now there are two options. There are two kind of approaches you can take to scale your application. If you refer back to our deck again, and if you refer to this slide, that is the system level metrics, we talked about CPU usage, request per second, or the memory usage. So that is option number 1, which is target tracking. The target here being system level metrics, or it could be step scaling, and you can understand the differences here. So target tracking means increase or decrease the number of tasks. That is a task which we created, which contains a Docker image. That is, it could increase the number of Docker image instances and attach it to the load balancer that your service runs based on target value for a specific metric. So we will choose that metric. The metrics here are, it could either track for CPU utilization, it could also track for memory utilization, or let's say application load balancer request count per target. That is, how many requests are we receiving for summarizing user given text for one Docker container image. So like we have to choose just one of these, and based on that, if it exceeds a certain threshold, so let's say this target value is that threshold. Let's say, if you remember the example I gave you, if our application is supposed to process 70 requests in a given instance, but if we receive more than that, then that 100 is basically more than the threshold which we have, and then we will be adding a replica of a Docker container. So that is exactly what's happening. I'll explain what scale out cooldown period and scale in cooldown period in a second. Another option is the step scaling, which is increase or decrease the number of tasks that your service runs based on a set of scaling adjustments, known as step adjustments, that vary down on the size of the alarm breach. So this is a different way we can scale our application, but we will be using target tracking so that we track the CPU utilization or memory utilization, etc., etc., and like scale out our application from there. The policy name, let's say we give it a name scaling policy. ECS service metric, let's just go ahead and click on the first one, or you could pick any of these. Let's go with CPU utilization, or actually let's just click the last one, application load balancer request count per target, because I think that's the example which we used. So the default value could be 70. You could actually change it. Scale down period, I'm going to use the default value is 300, and cool in period would be again 300. So what these two values means is that after the number of requests our application receives exceeds 70, let's say it jumps all the way to 100, and we keep on receiving 100 in the next instance, and again 100, and so on and so forth. But after a point, like basically, actually I misspoke. So initially we receive, let's say 70 number of requests, and in the next instance we receive 100. Then the load balancer will actually wait for some time before adding a new container, because for adding a new container we have to add a new EC2 machine, which 1 CPU and 3 GB of RAM. So it just waits out. it sees that, hey, I mean, maybe it could be that this is a one-off instance where we got 100 requests, but after 300 seconds, or if we actually get more number of requests which exceed this 70 threshold, then it knows that maybe we have started to get more traffic from users across the world. So that is when it starts adding more number of containers, each like more basically replica of our container. After that, it should also remove the container which it has added. And if, let's say, the number of requests start to reduce, and again, it doesn't immediately remove those containers, but it actually waits for these many seconds and then removes the containers. So that's what scaling out cooldown period and scaling in cooldown period means. So next, for tags, we won't be making any changes, and thus we'll just go ahead and create this service. The service will take some time. That is, demo service deployment is in progress. It will definitely take a few minutes. So in the next video, I'll show you like whatever service you have created, how you can make some more changes to it, some network changes, and then we'll just test that particular service with different like news or text articles, and we'll try to summarize those and then conclude the video series. So see you in the next section.